Hi everyone, and welcome to the Fingerprint Evidence Collection lecture. Let's get started. Fingerprint evidence is the most common individualizable evidence found at a crime scene. It's also the most commonly field processed type of evidence. In the Survey of Forensic Science course, you learned about the formation of fingerprint evidence, some basic fingerprint processing techniques, and the analysis process for fingerprint evidence. In this video lecture series, I will focus mostly on the searching and field processing techniques that are used at a crime scene to visualize and collect latent fingerprint evidence. Now, there are a few key concerns with fingerprint evidence. First, fingerprints are not always possible to collect. Fingerprints consist of 95 to 99% water, so they can deteriorate rapidly over time, particularly in certain conditions. There are also numerous transfer concerns, including the amount of oil on the fingers, the pressure and the length of contact, the surface characteristics, and any contaminants that are present on the surface or in the processing material. All of these conditions will affect whether or not the investigator is going to be able to visualize fingerprints on the surface during processing. Now, another challenge with fingerprint evidence is the compatibility between fingerprint processing techniques and DNA analysis techniques. DNA analysis techniques have strengthened to the point where we are able to analyze very minute samples of DNA. Known as touch DNA, this type of DNA is something that is left behind from the same contact that leaves behind fingerprint evidence. However, remember that fingerprint processing is much older than DNA. For that reason, it is only recently that we have begun to focus on the impact of fingerprint processing strategies on DNA profile recovery. As your textbook notes, it is important to consider DNA analysis when processing a scene or an item for fingerprints. Some fingerprint reagents do not affect DNA analysis, whereas others do. By carefully considering whether DNA analysis will be required and identifying what areas DNA will be conducted on, investigators can refine the processing techniques to ensure the best visualization of fingerprints while also reducing potential loss of genetic material. The last challenge, and related to the one I just mentioned, is that there are a number of processing methods for fingerprints. Some of these can be done in the field, but others may require more specialized equipment or materials, and as such are usually done in a crime laboratory. Investigators should make determinations on what evidence to send in for laboratory processing based on the crime type, the scene characteristics, the other evidence that's located, and any other important crime scene factors. Now, just to review, there are three primary types of fingerprints that we find at crime scenes. Latent fingerprints are fingerprints that are invisible to the naked eye. Patent prints are visible fingerprints, and plastic prints are three-dimensional fingerprints. Most of the processing methods that we discuss in our fingerprint lectures will focus on processing evidence for latent fingerprints, because that's the most common that we find. Now, when we process evidence at the scene in search of latent fingerprints, it's important to keep in mind what we learned with search patterns. You move from the least destructive to the most destructive. So first, you want to attempt to visualize the prints using the naked eye and potentially supplemental lighting. Oblique lighting works great for most latent print visualization, and it only requires a flashlight. Alternate light sourcing is also helpful to visualize prints on a large variety of surfaces, but because it requires more specialized equipment, this isn't always the first step, and use of ALS may be reserved for larger or more serious crime scenes. If the investigator locates a fingerprint, or if they believe a specific surface or piece of evidence contains fingerprints, they can process using either physical or chemical processing techniques. Physical processing techniques are often done at the scene using fingerprint powders, whereas chemical processing is more refined, but is often done at a laboratory due to material needs. Like your textbook states, the choice of processing technique is determined by the surface characteristics. Typically, non-porous surfaces that are smooth or lightly textured are the best option for physical processing powders. Porous materials like fabric or paper are best collected at the scene for future chemical processing at the laboratory. Proper documentation of fingerprints is crucial for ensuring evidence integrity and admissibility in court. Every fingerprint collected must be recorded with detailed notes and high-quality photographs. For each fingerprint lift, the procedure should be as follows. Step 1. Photograph before processing. If a fingerprint is visible to the naked eye, even if only partially, take an initial photograph before attempting any enhancement. This photograph should be examination quality, so it should include a scale, fill the frame with the fingerprint, and it should be photographed with the camera looking directly perpendicular at the surface. Include either an evidence marker or write the evidence marker on the scale so that it appears in each photo. Now, typically, you're going to assign each fingerprint an individual evidence number or letter unless they are grouped together. For instance, if you can see 3 fingerprints that are next to one another on an item that suggests like the item was grabbed like this, then you can use a single piece of tape to collect all 3 fingerprints, and they would be assigned one number or letter as a group. If the fingerprints were clearly deposited at different times, which you can use the orientation to determine, then you would collect each fingerprint individually and give them all unique evidence numbers or letters. Now, step 2, document the fingerprint and the surface condition in your field notes or the fingerprint lift card, and that'll depend on your agency's standard operating procedure. Record the exact location of the fingerprint as specifically as possible. For example, you can say that the fingerprint was found on the left side of the victim's phone with the top of the fingerprint oriented towards the top of the phone. Include sketches or diagrams of the object with the fingerprint location if necessary. The fingerprint cards in our class have a space for sketches on the back, so it's a really easy place to document that. Step 3 is the actual processing with either physical powder or chemical enhancement. And then step 4 is another evidence quality photograph. Again, this should include a scale with the evidence marker identified in some way as to identify the print, as well as fill the frame and keep the camera perpendicular to the print. Typically, when processing for fingerprints at a crime scene, you're going to be using physical powders. The best way to collect fingerprint evidence with fingerprint powder is a fingerprint lift card. This is an index-sized card that has a shiny smooth side and a regular writable side. You're going to use lifting tape to collect the fingerprint powder, after which you'll place the sticky side of the lifting tape directly onto the shiny side of the fingerprint lift card. This protects the fingerprint from any future alteration or contamination. Once you put the fingerprint onto the lift card, you're going to fill out the opposite side of the lift card with your case number, the date, and the officer information, just like you do with other evidence packages. Fingerprint lift cards can be stored together in paper envelopes to protect against dust or damage. In this course, you're going to have access to lift cards with shiny black and shiny white sides. The goal of the colored backing is to provide contrast for visibility, so you should choose a black or white lift card based on the color of the fingerprint powder you're using. White lift cards work really well for black powders and some of the fluorescent powders, whereas black lift cards work great with white fingerprint powder and other fluorescent powders. If you decide to process for fingerprints at the laboratory using chemical or other powders, then you're going to instead collect the entire object. The goal is to package the entire object without smudging the print. To prevent smudging during collection, investigators should handle the object as little as possible and only touch areas where no prints are expected, like the edge of the bottle or the trigger guard of a firearm. You should also always use gloves, and you may require sterile evidence handling tools to minimize contact with the surface. Once collected, the object should be wrapped in paper packaging, not plastic. Plastic bags should be avoided because they trap moisture, which leads to condensation buildup that could degrade the fingerprint over time. Paper wrapping allows for airflow, which helps preserve the print and prevents accidental smearing. When collecting fingerprint evidence, small mistakes can significantly impact the ability to analyze and use the prints in court. One of the most common errors is failing to photograph prints before lifting them. If a lift is unsuccessful, if it's smudged, or if it's improperly stored, investigators will lose their only record of the print. Another common mistake is storing fingerprint evidence in plastic bags, which, like I just talked about, can cause condensation buildup and degrade ridge detail over time. Inadequate documentation, like failing to note the exact location of a print, can also make it difficult to establish the print's relevance to the case. Another frequent issue is accidental smudging, often caused by excessive handling of the lifted prints or direct contact with the print area on an object. Even a slight touch can distort ridge patterns and render the fingerprint unusable. To ensure the fingerprint evidence remains intact and admissible in court, investigators must follow best practices. They should always wear gloves and handle prints with extreme care, using tweezers or by holding objects only in areas unlikely to contain prints. Each lifted fingerprint should be immediately secured onto a labeled backing card and placed into a protective envelope. If the print remains on an object, it should be wrapped in paper and marked as fragile to avoid accidental smudging. Additionally, all collected fingerprint evidence must be carefully logged in the chain of custody, ensuring a clear record of who handled the evidence and when. By following these protocols, investigators maximize the likelihood that fingerprint evidence will hold up under forensic examination and legal scrutiny. All right, well, that's it for this lecture. Thanks for watching, everyone.